In this video, we will explore the threading namespace. We will start by creating a console application and making a reference to the dodSON.Core assembly. First, we will create a class library which will act as a simple logger, and it will implement the IDisposable interface. It will contain the name of the file to write the logs to, the amount of time required before flushing the logs, and the maximum number of entries required before flushing the logs. It will contain a synchronization object since we will be doing threading, a list to contain the logs, and a thread worker to perform the work. The thread worker takes an execution interval, that is the amount of time to wait before calling the query function. The query function, which should return true or false, indicating whether it should call the execute function. The execute function, which will execute when the query function returns true. An onStart event, which will be run once when the thread worker is started. And an onStop event, which will be run once when the thread worker is stopped. The query function will test to see if there are any logs to write, and then it will test to see if we have reached our maximum number of logs, or if we have timed out. The execute function will simply flush the logs. And the stop event will also flush any remaining logs. The add method will take a single log entry and add it to the list of logs. The flush log method will first test to see if there are any logs to flush. If there are, it will open up the file and write each log in the list. Finally, it will clear the list. Since we are dealing with multiple threads, all access to the logs list should be wrapped in a lock statement. Finally, in the IDisposable dispose method, we will stop the thread worker. In the main application, we will create a simple logger. Giving it a file name, an execution interval, a flush time limit, and a log entry maximum. Then we will loop until the user presses any key. In the loop, we will wait for a random amount of time and then generate a random log, which will be added to the logger. After the user presses any key, we will again wait for the user to press any key, allowing the user to see the results before the console application terminates. Compiling and running the application shows the simple logger starting, the logs being added and properly flushed as either the maximum number of log entries is reached or time runs out. Pressing any key terminates the loop, dropping out of the using statement, which causes the IDisposable dispose method to execute, which terminates the thread and calls the onStop method, which flushes the remaining logs. Finally, we can bring up the simple logger text file and see that all the logs were correctly written. This demonstrates how easy it is to create and consume the thread worker. But you're probably asking yourself, why not just use the .NET Task Parallel library? That's a good question. The .NET Task Parallel library uses threads from a thread pool, a queue of pre-made threads designed to be used for short background tasks and returned quickly to the thread pool. so that they can be reused without incurring the cost of creating new threads. However, the thread pool has a limited number of threads that can be active in a process simultaneously. If all the thread pool threads are busy, additional work items will be queued until threads become available, and a large number of blocked thread pool threads might prevent tasks from starting. It is also important to note that the .NET system itself uses the thread pool in your application to do a variety of work. For example, asynchronous I/O, timer callbacks, wait operations, and asynchronous method calls to delegates. For quick and simple, non-blocking tasks, it would be best to use the .NET Task Parallel library. However, if you have a thread that is going to live for the entire lifetime of an application, or block for long periods of time, it would be better to use the thread worker and not consume one of the limited number of thread pool threads. This video demonstrates some of the basic functionality of the threading namespace. See the dodson software library help file for more information.